Sir, shall we start?
Yes, ma'am. Yes.
Good afternoon, everyone, and welcome back to our for the new session. Last day of the FDP, ATAL FDP, session 11 and 12. Today it will be delivered 11, 12, and 13. So it is my great pleasure to introduce you all, Dr. Sanjay Singla, sir. Sir is serving as a professor and research coordinator in the Department of Computer Science and Engineering at Chandigar University with over 23 years of teaching experience. Dr. Singla sir has established himself as a distinguished academician and researcher in the field of computer science. In the year 2025 itself, Singla sir has made significant research contributions with 15 conference paper, two Scoopus indexed journal papers Q2 and Q3, and two SCI indexed Q1 journal papers published. Additionally, sir has three SCI indexed journal papers under review. So his innovative mindset is reflected in his 12 patents, out of which two are published in 2025 itself, and two more have been recently filed. So, Sir has also successfully organized two major academic events in this last 3 months itself. That is 1 week FDP on quantum computing insights for educators, concepts and applications, which is sponsored by CDAC Mohali. That is June 2 to June 6. Sorry, the International Symposium on Data Intensive Computing DICS 2025, which is held on June 16, 2025. So these are the two major events sir has conducted, and over his career, Singla sir has authored 180 publications, including 29 Scoopus indexed papers, 5 SCI papers, and 75 conference papers, alongside several publications in UGC recognized journals. Sir is a research supervisor and has guided 9 PhD scholars to successful completion, and he is currently mentoring 3 PhD students in emerging areas of computing. His academic leadership, extensive publication record, and commitment to innovation continue to contribute immensely to the research ecosystem of Chandigarh University and the broader academic community. So today, Dr. Singla sir will be delivering the sessions on 11 and 12 on topic hands-on applications of AI in healthcare and generative adversarial networks. So we are glad to have Dr. Singla sir with us today. Sir, we warmly welcome you and invite you to begin the session, sir. And we also welcome our principal sir,
Thanks, ma'am.
vice
Thanks a
principal
lot.
sir, vice principal madam, all the HODs, staff, faculty members, and all the participants of various institutions and our PDACEK College of Engineering to this last day of the 6-day FDP. I welcome you all. Over to you, sir. Singla, sir.
Okay. Thank you, ma'am. Thank you, Jashir, ma'am, for giving me such a nice uh, presentation about me.
Uh,
I am very excited to give the presentation and thankful for the giving me this opportunity. Network issue there. Giving me time. Ma'am. There is some network issue there. I see.
due to flood and all, sir, I think.
No, maybe. Just, I'm shifting my position. Give me 2 minutes.
Okay.
Yes. Not is clear, sir.
Hmm.
Can I share my PPT?
Yes, sir.
Thank you. I I think my PPT is visible.
Yes, sir. Yes, sir.
Okay. Thanks, Yashir ma'am, for giving me the opportunity to present my topic hands-on application of AI in healthcare.
It's
I'm
our
thankful
pleasure,
to,
sir.
I'm thankful to the principal sir and vice principal sir, all HODs. And I congratulate the teams of the PDA college. Okay, they are organizing this F, ATAL FDP on emerging trends in AI for smart innovation and sustainable technology in industry. This is effort of all PDA family faculty members to bring this FDP to their college and giving knowledge and share knowledge to all the different participants joining from the different institute in India. Myself, I'll only told by ma'am, introduced by ma'am. I am working as a professor and research coordinator in Chandigar University. So my topic is application of AI in healthcare. So first, we start with the basic term is AI. We understand artificial intelligence. That means we will give a knowledge or intelligence to the machine that will behave like a human being. It will like to mimic as a human intelligence. So in healthcare, AI supports diagnosis, treatments, drug discovery, and administrations. AI has a very it is a work as a helpful tool in healthcare in different terminology, patient care, or remote patient care, or you can say robotic surgery, and hospital workflow, all easy of the administration task, drug discovery, drug treatment, patient treatment, all are the application of AI in the healthcare. So we can use machine learning because all they are the subdomain of the AI, machine learning, deep learning, NLP, natural language processing, computer visions, all are the subdomain or part of the AI. AI superset, all are the subset of this, and this will help for the make the AI fantastic tool in the healthcare. Because why the AI is in healthcare? Because AI works, machine learning or deep learning works on the large data sets. Okay. So this generate healthcare generates large data set, massive amount of data, medical images, records, X-rays, MRI images, CT scans, whatever, genomics, whatever. Again, the main role is a doctor, and we know population is growing exponentially, and there is a lot of shortage of doctorates everywhere, in urban, semi-urban, rural area, everywhere. There's a shortage of doctorates. As mainly the specialized doctorates. Okay, we have a lot of MBBS doctor, but specialized MCH MS is very rare. We need a tool, a technique, a technology for the faster, accurate, because accuracy matter here, and personalized healthcare. AI provides efficiency, accuracy, and better patient outcomes. That's why AI is useful in the healthcare. There are different categories of AI applications. First is a diagnosis, medical images, pathologies, screening, maybe X-ray screening, whatever, MRI screening, whatever. Everywhere for diagnosis, you can use the AI. Predictive analysis, disease progression, patient risk. For this purpose, also we can use the this machine learning or AI. Treatment support, robotic surgeries, because it is for the precision medicine. For that, we can also use treatment support. We use the AI. Administrations for record keeping, your scheduling, billing, fraud detection, insurance fraud detections. We can use AI. For in research, we have seen the COVID era, the fastest drug discovery, molecule discovery out of lot of billions of molecules. We can find the best molecules for the. For this, we can use the research. We can use AI in the research. So Why AI matters in the healthcare today? Because it helpful in enhance accuracy. It is helpful in the enhance accuracy, accelerate discovery, one second, enhance securities, personalized care, discovery, and optimization operations. We can use this healthcare. We can use this healthcare. So, this is the because of AI. So we can use for the drug discovery, for the acceleration of discovery, drug development and research, hospital workflow, administration task, personal care, enhanced accuracy. This is again matter of concern for AI in the healthcare. This is the okay. AI advanced diagnosis, powered medical imaging, seeing what human cannot. So AI can do powerful job, wonderful job, which cannot be done by the human, or it can be done by only by the you can say super specialist doctorate only. And you know there is a lacking of super specialist doctors. So AI has a profound impact in the medical imaging. AI algorithms can analyze X-ray images, CT scans, MRIs with remarkable accuracy. This is a cannot be done by the simple human eyes. This allow for the earlier and more precise detection of anomalies and leading to timely intervention and improved patient outcomes. Example is Jabra Medical Vision AI, which is demonstrate have the capability to detect lung cancer nodules. These are the nodules, okay, lung cancer nodules, has a better accuracy than the traditional methods. This this early detections by the AI tools or methods help in the early detection of disease. So, and proportionally when the and help in the prevention of further disease, and treatment can be given in the early stage, and disease can be cured. So this is a wonderful application of AI. And one of us under my guidance, we have make a one project for the students. We are giving the chest X-ray images to the system, and it able to detect infections in the chest. So, and that accuracy is around 97.5%. So, so we have talking with a lot of this doctor who are specialized in the chest disease in the PGI. We are concerned with the PGI, and we will make our system more and more trained so that it can be helpful have in the diagnosis of early disease. And we will try to increase the accuracy by 99% to in the end of this year. So this is my project, MPGI Chandigarh. Then personalized treatment plans through AI analytics. So AI has the ability to analyze complex data because this healthcare sector has a lot of data. So, and data can be handled very easily by this AI. This allows us to move beyond the standard protocols, offering treatments that are not just effective but uniquely suitable to each patient's genetic and psychological profile. So that's why this is the main AI in the healthcare. We are discussing different application of AI. AI in a medical imaging and diagnosis. The first point is AI in radiology. The AI can detect fractures, tumors, lung infections, radiology images like X-rays, CT scans, MRIs, PET scans. This help in the faster analysis with reduced human errors. AI in pathology, you can say sample of the blood, whatever. to help. So AI can analyze the samples of the bloods, biopsy, and histopathology slides. Slides means we take the bloods from the slides and we can find that various type of disease there in the slides. It will helpful in the identification of cancerous cells with high precision, help pathologists reduce reduce their workload. This is a helping tool for them. Now Google AI for the retinopathy for the eyes disease. Google developed AI for the diabetic retinopathy. Those who are suffering from the diabetes, they have a very they have huge chances for the retinopathy disease. Okay, so this Google developed AI tool for the retinopathy screening. So this Google tool can detect retinal damage from the eye scans. So we'll take the eye images and we'll check the retinal, how much infection is the retina is infected in the eyes. This accuracy of this tool developed by the Google is as compared to the ophthalmologist. They're the eye specialist. Okay. So it is used in the India and Thailand for mass screening today. This tool, because you know very well, okay, there's India is the largest population having the diabetic. Main chances of the retinopathy disease is too high in the India. So that's why this tool is very effective, and doctor are using massively here. Then AI can be used in the early disease detection, like in Alzheimer. Alzheimer means that is a related with the brain changes. There is a one movie with the Amitabh Bachchan movies there who has this disease Alzheimer. So this Alzheimer disease has a brain pattern changes. Brain pattern start changes, and there is a, you can say, shivering. Uh, you can say writing pattern, standing pattern, or running posture, and will be different in the Alzheimer disease. Okay, so this AI, my one of the student, he's doing the thesis under me, under my guidance on this disease. So, we are working on the voice as well as written pattern, CSV files, different data sets to how to be early detect the Alzheimer disease. So AI will be helpful detect the early brain pattern changes. This is the images. Okay, so where there is a voice also, voice pattern will be changed when the person or patient suffer from the Alzheimer, and movement pattern will be changed. Okay, hand gesture will be changed. This is heart disease. AI can analyze ECG, electrocardiograph, okay, printouts for irregularities. Cancer, it can find micro patterns invisible to the human eyes, so that can able to help to find the cancer disease. Then another role of AI in the predictive analysis and patient care. It will use patient history and data for risk prediction. If you are doing the diabetes, okay, what is your history, your father history, mother history, grandpa history is there, smoking is there, BP is okay. This is a for different type of factor we collect to find the patient history, analyze the data from the patient history to find the disease, help prevent hospitalization and chronic disease. This will early detection will help this one hospitalization. Like diabetes, heart disease, kidney failures, all are the examples of the predictive analysis in healthcare. Remote patient monitoring. So you know there's a Apple Watch, Fitbit Watch. Okay, uh, there are a lot of now wearable devices, best IoT and plus AI embedded watches are there, wearable devices are there. For the remote, they will check the regular BPs, heartbeat, whatever. Okay, pulses, pulse rate. So this will monitor glucose, heart rate, sleep patterns, etc., walking habit. Okay, this enables telemedicine and home-based care. When there is some unwanted patterns, alert will be goes to the doctor, and a doctor can address the issues and can give a treatment to the patient, because it is only for those patients which are the on high risk. Okay, this will be can be given. Okay, so now in the there is a boat company that has introduced some devices that will check your glucose 24 by 7 and give a report, weekly report to the doctor, so the doctor can analyze when the glucose level is going up and down, so that the drugs can or insulin can be imposed, can be given to the doctor, can be increased or decreased as per the glucose level. There is another device, AI based device, that will check the glucose level, and if it's required, it will be automatically give a insulin to your body. So this is another remote patient monitoring. So AI for chronic disease management and remote monitoring. So this is a Bigfoot biomedical AI system. Bigfoot biomedical AI system which assists individual with diabetes in managing their insulin dosing automatically. So this is a I am giving I earlier told you there is a Bigfoot biomedical AI system. So this is a check the or monitor the glucose level in the individual and give insulin automatically. By continuous monitoring glucose level and apply AI algorithms, system can recommend or even deliver precise insulin doses that will be significantly reduce the burden of self-management and mitigating the risk associated with the glucose fluctuations. For those persons which are on high risk of the sugar level, their fluctuation is very high. So this device will be checked glucose level automatically and give a you can drops of insulin or doses of insulin so that level should be maintained. So this outcome of such type of devices or AI integration in the healthcare, it will improve patient self-management. This patient gain greater control and understand of their conditions. It will reduce hospital admissions because they are this is monitoring automatically, insulin going automatically. So burden on the hospital is also less, and enhance the quality of life, because when there is fluctuation, so maybe there is a lot of disease may become automatically, like heart heart disease, kidney disease, maybe there issue will become. So all this will be regulated, controlled by this AI integration. Third is AI in the drug discovery and precision medicine. So AI can be used in the drug discovery to reduce time and cost of new drug development. AI can screen million of molecules for effectiveness. So it will can search effectiveness. So for it can search number of molecules available for a particular disease and can find out the best molecule for the that particular disease. Example is a for AI tool is a Autominet, DeepMind, AlphaFold. These are some AI discovery tools there. We have seen the case studies in the COVID-19 drug repurposing. We know in COVID-19, the main issue with the you have a problem of lung infection is there, throat infection is there. So this AI identified existing drugs available for this throat infection or lung infection or shivering, whatever, temperature, whatever. And it will first identify the drugs available for these different infections and accelerate the vaccine development using protein folding prediction, which so, so help in the find the actual drug that is will be helpful for this type of cause, this type of disease. So it help in the saving number of years that will require for the trial and error, because there are number of trials and methods are there. So it will help in the trial and error methods and reduce almost 65% time for drug discovery, because drug discovery take a lot of 1 year, 5 year, 10 year, 20 years, whatever. So number of time reduce to 90 up to 90%. using the AI in drug discovery and precision. So AI in surgery and virtual assistants. So AI in robotic surgery. There is a robot, DAY6. It assists surgeons with the precision operation, very accuracy, high precision, high accuracy. AI suggests incision points and movements to minimize invasive and faster recovery. It helps in the faster recovery of the things. AI virtual health assistant like AI chatbot answer patient queries. We can now with the help of AI, we lot of colleges and universities have made the chatbot for the admission purpose. So chatbot can be developed. A lot of hospital also made the chatbot bots. So using the different queries and generative AI, we can also make a chatbot using the LLM. And using LLM, we can give a patient queries and patient get the satisfied answer for that one. So there's a mental health chatbot is already available, BIPSA, WooBot, to medication reminders and lifestyle supports. They help in the all reminders for medications. When you have to take the medicine, you have not take the medicine, or yes or no, whatever. This will be helping the improvement of the lifestyle. Then AI in the healthcare administrations. So AI in the hospital management. So AI optimize staff scheduling because it gives the patient the time and availability of the doctor is not there. Okay, so this will help in the overall hospital workflow. So it will help the patient also. Patient will be comfort because waiting time for the OPDs will be reduced. Or predict resource usage. Beds are there, equipments are there, or, or your surgery room is available. Not all this will be scheduled properly because we are using the OI in the AI in the optimization and resource scheduling workflow also in the hospital also. We are using the, our universities. We can use in the all of this. So AI in the insurance and fraud detections detect fraudulent insurance claims. It will identify abnormal billing patterns because there are a lot of insurance which can be fraud maybe. So to fraud transaction, we are using the AI in the fraud transaction. This is also abnormal billing pattern. So this is the administrative job in the hospitals. So AI can help in the administrative jobs and make the workflow easy, and it will help the transparency in the healthcare payments. Okay. So case studies, it will reducing waiting times in USA because AI scheduling system is almost implemented in US hospitals. So it will reduce waiting time, estimated waiting time by 35%. So it will be help in the better patient satisfactions to this. So AI future trends and conclusions. So AI plus smartwatches can helpful for the chronic disease monitoring. AI and VR means virtual reality plus AI can be used for the pain management and rehabilitations. So in future time and coming time, we can use AR, augmented reality for the guided surgeries because we are using ARs in different fields in a mechanical, civil, electrical, computer science, lot of AR. So in Chandigar University, we are also establishing AR, VR, MR lab. So for giving a simulation of the actual environment to it help. AR plus AI will help the surgery, precise surgery in the patients. So this will give simulation environment so that there will be it will be training of the doctors also. So doctors actual they no need of that human body or animal body. So surgery can be performed in the simulation environment, and this will help a great help to the hospital also and the medical uh, institute also. Limitation in the stick of AI because it requires large label data sets. Risk of there's a where there's overall accuracy depend upon the false positive, false negative, true positive, true negative. So this is the risk of this one. So model bias due to demographic imbalance are there. Data because it's based on the data also. AI sport should sport not replace clinicals. So this is 1 second. I'm going down because of lot of flood issues there. चार्जिंग नहीं कर रहा है उस पर नहीं है ना sorry. Yes, so this is a limitation of AI in diagnostics and limitations. Okay. So we are discussing the implementation part. So we know that there are three type of learning is there. Mainly the supervised and unsupervised and reinforcement learning. So we are working on the first is the regression, that is a type of supervised learning. Everyone is hearing to me? I am audible? I am audible or not?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Okay, okay. Thank you. Now we are going for the regression. We know very well that regression is a supervised learning, and to how we can identify कि our data set or database is given. Okay, on this data set we can apply the regression or clustering or classification. So the main goal, the main prediction is a continuous. The having the when the values is the continuous numerical values. So means we should apply for the regression. We should go for the regression. So input is a there are a number of features are there that will be all are the independent, maybe independent variables are there, and one outcome will be there that is the dependent variable. So algorithm we can use here in regression is a linear regression, polynomial regressions, decision tree, neural networks. We can this type of algo we can use. Main is a linear regression or polynomial regression we are using here. So like house price prediction, stock price predictions, patient blood sugar level, diabetes, healthcare. These are the AI application in the regression. So we have covered regression. Second one is a classification. Classification, the our target is a categorical labels. The data is there labeled, and data has a category 0, 1, cat versus dog. This person have disease or no disease. Email is spam or not spam, or 0, 1. 0 means yes or true or false, whatever. This type of target target output will be there. That is called prediction. So we have a number of columns that call attributes, that call prediction. The output is a we have to categorize in the two classes. This is a 0, 1 or spam or not spam. This example is a spam, no spam, disease, no disease, medical diagnosis, cat versus dog, image recognition. Algorithm is a regression, logistic regression. You can support decision tree. We are using the SVM mainly, random forest, decision tree, neural networks, all are we are using here. For the clustering, we say ki group data into cluster, they no labeled, no predefined label is there. This is an unsupervised learning. So we will clusters based on some similarities. some patterns, something is common. So we make a clusters. So we have features that are not labeled. So we will cluster. We will make a one cluster, two cluster. Cluster IDs will be there. We will cluster like customer segmentation in marketing. Because with then suppose I have a marketplace. I have a big shopping mall. I have to categorize my best customer, good customer, or you can say uh, frequent customer is there, not good customer is there. So, so I have to give some discounted price to my best customer or good customers. I have to make a segmentation. I have to make a grouping. So, so I will check my data set on the different type of patterns. What is their buying, how they much frequently, how frequently they buy the things from my shop. Okay. So and what is the paying habit is there, values, much values for which value they are purchasing the items. So these are the on the basis that I can make a segmentation. Patient with similar symptoms, okay, like corona, we are not able to identify earlier it is a corona disease, but those we start grouping. These are the patient with some type of disease have a maybe corona symptoms there. COVID-19, COVID-19 is there. So I will have with some documentation, topic clustering. We can do that. So main we are using here the k-means is the one algorithm, and DB scan is another. We are using properly using these two. So I think we are more clear about the regression, classification, and clustering. This is a table we have learned very well. We know very well. This is a regression is a supervised learning, classification is a supervised learning, clustering is unsupervised learning. The value here for the regression will be contiguous value, numeric. Here the data will be labeled true, false, mainly disease or no disease, like this. Here is a group, number of group will be there. Group 1, group 2, group 1, group 2, group 3. Example is blood pressure, diabetes, diabetes. Again, maybe diabetes can take here example diabetes. Disease, kidney disease or not? Yes or no? Kidney disease, yes or no? Kidney disease or not kidney disease? So iris is blue, iris is a blackish. Oh, we can go for the group segmentation, depend upon some symptoms, common symptoms. So this is a we can mean one cluster. This is two. So there are three clusters here. One cluster, two cluster. We are trying to make clusters. This cluster is called clustering. Algorithm we have discussed mainly within the linear algorithm regression and polynomial regression. Here we use the SBM, a decision tree, means decision tree, neural networks. Here we go for the k-means and DB scan. So regression is measured in the form of RMSC, MSC, R2, root mean square error, R square. Here classification we go for the accuracy, Evans score, precision, recall, precision. This is, I think this is visible. Okay, not really. Okay. So here is a it is a cluster is made. We go for the chill out score. This is the for cluster. So how we can find different type of data sets, and so this is a list of data sets. We can go for the machine learning deep learning. So we know very well the Kaggle is there. So there are a lot of data set is given. So there is a lot of data set is there. So we can find different type of data sets available. This is a Google data sets, IBM collection of data sets, Kaggle data sets. Main important this is a Hugging Face data sets. This is Hugging Face. Lot of data set is available. Audio, document, images, whatever. All data set is there. Lot of data sets is there. Lot of data sets. You can go for 4,90,570. You can for uh, diabetes. That is bad. These are the data set. Diabetes data sets. Okay. So lot of data sets. Cattle disease. Cow disease there. Dairy cow. Lot of data sets. So very big. Computer vision data sets. Open machine learning data sets. Data set list. Papers with code. Code is also mentioned. Different papers are there along with the code. Is there. Only machine learning benchmark data sets. You say machine learning data sets. We are going for the Alzheimer disease for my PhD students. We are using this UCI machine learning repository. Visual data discovery for computer vision. Overflow public dataset for computer vision. 23 best free human annotated dataset for machine learning. They all the different datasets are there. This is a online courses for BTech students, MTech, PhD students, so that they can be expertise in the machine learning or research. So how these are the courses for the researchers, PhDs, and PhD scholars, master scholars, research for impact, whatever. There are different research methodologies, advanced data analytical statistics methods, experimental design and data collections, literature review and critical analysis. All our link is given for your research. You can go all those threes to find this. Now we can use the best tool is a PyCaret for the machine learning. So we can this PyCaret library is there. So this is a it is a bundle of machine learning algorithms. Only 3 lines of code is required for comparison of 20 models. So writing a research paper using the PyCaret is very easy. Only 3 line of code is required for comparison of 20 machine learning models. Okay. The PyCaret is level for the classification, regression, clustering. You can use for this one. Okay. So just the 3 line of code is there. From PyCaret dataset import get data, import regression. So we have from get data, we have taken the insurance data set. Then we check the this is a type of regression, so we change the charges. Charges are numerical values. So for regression, we know very well continuous value. Okay, this is the values, and we just write a code compare models. Compare model will automatically compare different models. This is comparing 20 models, giving their value MSCs, RMSCs, R2. The root mean square. The best one is the root mean square is having a minimum value. So GBR, gradient boosting regression. This is a having. R2 is a best, higher value. So this is the this one for this data set insurance, it is better. So I am so you can use uh, with the code, but the issue with that PyCaret today I am going to implement again because I did it 6 months back. The PyCaret is not working on the PyCaret is not working on the PyCaret is working on the Python, which is a 3 point up to 3.11. Now this Google Colab supporting 3.2. So this so this is not working when I wrote pip install PyCaret.
ವಾರಕ್ಕ ಇಲ್ಲಿ ಕೇಳು ತಿಂಗಳಿಗೆ 4,000 ಅಂದ್ರೆ 24,000 ಆಯ್ತು. ತಿಂಗಳಿಗೆ 24,000
ಹಿಡೀರಿ
ಇದು
ಲಾಸ್ಟ್
4,000 ಅಂದ್ರೆ ಇನ್ನ 6,000 ರೂಪಾಯಿ ದಿನ
7:30 ತನ 6:30ಲಿಂದ 7:30 ಟೆಸ್ಟ್
ಅದೇ ಕರೆಕ್ಟ್ ಯಾಕ ಮತ್ತೇನ್ ಬಂತು
So we are installing PyCaret. Uh, we are installing the PyCaret. I think that's an issue. Yes, an issue. I don't know. Network issue not there. There today, because the some issues coming in the pie carrot, we are not able to run the pie carrot. So I have in the last moment, uh, because the pie carrot support 3.9 to 3.11, but this now this Google Colab coming with the Python version 3.12. That's why PyCarrot is giving some error. Otherwise, it is a wonderful tool. So we can go for the one is a another is a LegitPredict. So we can go for the LegitPredict alternate of the PyCarrot. The PyCarrot is super, but it is also good LegitPredict. So we can go for the LegitPredict, and first we will install the LegitPredict. Okay. So already installed this one. So from this LegitPredict, we have to go for supervised model that is called supervised logical regression. We have go for the data set, diabetic data set. Then we have to go for the test and split information. It is installing. I think it's taking time. Okay. When will be it will be installed? So we have import the Skyline. We have upload the all data sets. So here we are learning only the diabetes. So we have all data set we have import. So we can print the data sets. We have print all data sets. There is a data whose data sets like circles, globes, the data images, breast cancer data is there, and low digits is there, low diabetes, this data set is there. Earlier, here we call only low diabetes. Here, all database name is there. One is a low diabetes. So when so we can print line by line, these are the line by line because this is a you can you're not able to understand. So I print all data set in the line by line. Low diabetes, low breast cancer. So from sklearn also have a data sets. PyCarrot also have data sets. We can learn from the PyCarrot. I think PyCarrot is not running properly. So these are the data sets there. So we have load iris dataset. So now from this we get the datas in X, target value in the Y. So we all features name is there, all target name is there. So this is a target value is there, feature name is here. Because this is a because now iris data there is the petal length, petal width, septal length is there. There are three type of disease maybe versicolor, virginica, acetosa. These are so this is a these are the values. First five rows of X and first five rows of Y. So target values data set is there, and this is a X values are there. There is a septal length, septal width, petal length, and petal width. These are the values are given. So this is a classification example. This is a diabetes. We also gave for the diabetes X value, Y values. Feature is a feature is a your feature is a age, sex, body mass, BP, other features S1, S2, S3, S4 are the other different features are there. So these are the all are the numerical values are there. Numeric. There is a no the 0 1 value is there, whatever no value is there. So we can 20s we can check out. We can run it. I think there is a some network issue maybe there. That's why this is a all feature will be, although this was a 5G, but what issue. So we have to diabetes dataset had taken their shape, how many rows and columns. So this is X has a data, actual data has a 10 features and 444s are the records. Y has only this because this is one column, vertical column will be there. So there 442 value will be there. This is corresponding to this one. So this is a X data, this is our Y data is there, 442 values are there. Now we have split X values and Y value into the 20% test and 80% is a for the training. So we have taken random state. Now we have predict models and we use lazy regression, different type of warning, warning true. So this is a all lazy regression we are using, and we are using this one. We are training all models based on the regressions. So simply we are comparing different models and predicting their values models over there. So otherwise what we have to do, we have to use different type of regression models, train them, test them and get the output. So this is a one command we are getting for the print models. This is the after 100% completion, all models, it is showing the this all these models. These are model and their comparative values. We can copy cells, copy simply we can copy here and put in the Excel for to make a chart. We can make chart here also. Or we can make a chart here also. And this is the time taken by the different models. So here we can check root mean square error. Lower is the best one. This is a lower to high. So worst one is a kernel release, large MLP regressor, Gaussian. This performance is poor. This is a large CV, large CV and lasso CV. This performance is almost same, 52.87, 52 point, and time taken is also less by these three. This one is best out of this lasso CV. Lasso a large CV is better because it's taking 0.2 seconds. The performance is same. Both are same performance. So in this way, we can write a paper using different data sets. And we can also upload the data set here in Kaggle and give a path and can compare different data sets, what are time taken by them, what are their R square values and RMSE values, and then we can find the we can make a charts, comparative charts, and can show this is a example. So this is a diabetic prediction models used in the diabetic prediction accuracy of the RMSE error. Second one is a example is a classification because diabetes is a numerical values. Classification iris we have already seen. This is a breast cancer is there. I think this is running already. Not running. Okay, this is some error. I think system is not working properly. This one breast cancer. Again, we have trained different models. This is a classifier. We have taken as a classifier. Here, in case of this one, diabetes, we have taken a regression. So here we have taken the classifier. One thing, regression. This is a regression, lazy regression. We have taken a regression. Here it's a classifier. So just we have a load the breast classifier and we have taken the x value and y value. We divide that into the uh, test and training data set and we have to use lazy classifier and give a all parameters just compare the models. So this is a again it will print the all outputs. Okay. I think there is some issue with the network. Maybe it is not running. I have to check out why. So this is a so using this healthcare predictive analysis chatbot or diabetes prediction, breast cancer prediction, iris prediction. So we can go for the Alzheimer's disease. So this is the application of AI in the healthcare. How this AI will be helpful in the early prediction of disease and to help in the supporting of the human life. Okay. Because there is lacking of expertise, doctorate, and they have a lot of the patient is increasing exponentially. So experienced doctor is not there. So this AI tool can assist the doctor but cannot replace the doctor. Help in the prediction at to high accuracy level. That can help in that. This is a I think there's some network issue maybe there. That's why it is not running properly. Otherwise, there's no issue and working properly. So uh, we can use this lazy predict library to compare different models. We can use the PyCaret. We can use the PyCaret. When And we can use the PyCaret in Anaconda, Jupyter Lab also we can use in Jupyter Lab. But if Google Colab not supporting because Python version is high. So when PyCaret release the new version or the updated version, we can use this library. A wonderful tool, because there's some issues coming in the when we copy and pasting this one data. Okay, so in PyCaret to give a properly tablet form information, we can down the CSV file or Excel file. We can make a chart, or we can go for the Python or visualizer, different visualizer tool to make the different uh, graph. Okay, so this is the beauty of the PyCaret, but you can also use Lazy Predict. It is giving the good results, and same result equivalent to this one PyCaret, and the parameter is some less, but it is okay to find the results there. So we have discussed about the regression clustering helpful in the early prediction of disease in the human. You can use for the all animals or whatever. Okay, so different animals disease prediction can be used and whatever. So this is from my side. From my this is the end of today presentation, or this session presentation from my side. Sorry for disturbance coming because of network issue, because in Punjab region, you know, there is a flood situation is there, so maybe light issue is there and internet issues coming there. Lot of, okay. So we are all having a working from homes because university total shut down for 10 days.
Okay, sir.
Any query from any side?
Any questions, participants?
Yeah, good evening, sir. Good
Hello.
evening.
Good evening. Good evening, please.
Yeah, this is the Dr. Shyamkumar Patil from Savidya Institute of Technology, Bangalore. Sir, my question is,
Okay.
which one is more efficient for analyzing image or protein sequence of disease?
Which one is more?
More effective and efficient. So,
Mhm.
image or protein sequence to analyze the disease by using AI technique.
Okay. So you want to go for the protein detection, na?
Yeah, yeah.
Okay. For which type of
Especially
disease?
diabetes protein sequence, I think healthy and diabetic patient are changing, no? Amino acids.
So this is a effect. This protein sequences is there, cases there in the diabetes protein
Yeah, yeah,
sequence.
yeah. You can find in almost all the diseases.
Okay, for disease. So I think you can use one of the algorithm that is called DB scan also.
Yeah, DB scan is okay, sir. But
DB scan is because I have used this protein sequences for a different type of disease in my previous research. So DB
okay,
scan result from the others, I found a good one.
yeah, yeah. So I
You
think,
can you can go for the hybridization. Okay,
yeah, yeah,
or you can go for the hybridization because uh, you cannot say one tool is fit for everyone for
correct.
applications. But I think the result will with a DB scan maybe have a good accuracy.
Okay, sir. Because what happens, no, image sometimes.
You can send me the data set little bit or link. I can
Okay.
suggest the which one better
So
be.
you can get it from the data set like NCBI, sir,
And
or
see,
Unicode
actually,
NCBI.
actually, there is a lot of problems coming today because we have,
Okay.
as a research coordinator, I have tied with the PGI Chandigarh.
Okay.
Okay, PGI Chandigarh is the second largest medical institute in India.
Uh-huh. No, sir,
And
data set you can get it from
if you
NCBI.
send me the link, sir, so that
Okay.
I can suggest you which tool can be better. AI tool is better for
Yeah, yeah.
that. Understand, na?
Yes, sir. Yes, sir.
Okay, so
Yeah.
I will suggest you by tomorrow.
Okay, sir. Sir, what happens now? See, AI in almost all the field. AI
Yes.
in medical, AI in agriculture, AI in medicine, AI in surgery, AI in hospital management,
Hmm.
AI in insurance. Almost
Everywhere, yeah.
wherever you go, AI is
You will
there.
find the AI. Yeah,
Yeah, yeah. Is
yeah.
it more intelligent than the intelligent person?
More.
Intelligent person is there, no sir. Doctors are there, these
Oh, yeah,
farmers
yeah,
are
yeah.
there.
Sir, we have. one of my student has
Yeah.
implemented X-ray chest machine in Apollo Delhi.
Okay, sir.
Okay, so what we have did, we have make our accuracies a 97.5% there.
Okay.
So when the patient goes to the doctor, before going to the doctor, we scan the machine, scan the X-ray in that machine,
Mm-hmm.
and give the result to the patient. Patient carry that result to the doctor, and doctor will analyze. Okay,
Okay.
so it will assist the doctor. Yes, this may be conclusion for the
Okay.
prediction of the disease. This is a maybe chances of disease out there, because we are human beings. After
Correct.
after checking 20 patients, we will feel tired.
Yeah.
Every time we are not okay. You can say today I have this flood issue in my area. Okay, I am not
Mhm.
giving my lecture so much enthusiasm with my
Yeah.
full energy. If I am there in the PDA college, I can give physically more accuracy. Understand my point? No?
Correct.
So,
Correct.
so we are as a human being, we changed with the time. Okay, the
Okay.
machine learning algorithms, they assist with their accuracy, error-free algo. So all they are not a replacement, but they are assisting tool to the doctorate and to ourselves also as a patient.
Okay, sir. Sir, in future,
Hmm.
this artificial intelligence is going to replace the intelligence?
No, sir, no.
No.
Human is a super billions
Yeah.
neurons that
Okay.
can never replace. Emotions are there. A lot of things are there which
Yeah.
cannot be replaced by human beings. So
Yeah.
I'm reading an article
Yeah.
yesterday.
Yeah.
So he said that earlier
Mm.
there was people are writing on their own paper, copy and pen. Okay,
Yes, sir.
everything they note from their lectures or they learn from the environment, they write out. Then printing comes in the pictures.
Yeah. Correct, sir.
At that time, lot of people oppose this. Keep when printing comes, so this that writing habit will be not there. Okay,
Mm-hmm.
but when printing comes, people learn more and more.
Yes, sir.
Then ki mobiles comes, internet comes. So we are get habitual.
Correct, sir.
We should adopt all this then. Okay,
Yes, sir.
so these machines cannot replace because we are the father of machines.
Correct.
Yes, yes.
Yeah, sir. Actually, it is the your session is after post lunch session.
Hmm.
So I was feeling a little bit dozy, but because by listening you, so I felt it is
Actually,
actually,
sir, there is a network issue. Otherwise,
yeah, yeah.
I
So
will show you the comparative studies and making a chart properly, how this will work properly. Because as a, because in our university, madam know, Jashri ma'am know,
yeah,
in
yeah.
our university as a research coordinator, in every semester student have to write a paper.
Yes, sir.
So, so we will
Quite
go.
interesting. Your presentation, you have taken, you started from the basic to the complex one, sir.
And
Quite
I
interesting.
can make a chatbot also for you. How
Yes,
you
sir.
can for your hospital, for university also.
Yes,
What
sir.
are courses are there? What are admission process there? What is the fees? Okay, you can make a chatbot for using LLM. No issue.
Yes, sir. Yes. Thank you, sir. Thank you.
Okay, thank you, thank you. Jashri madam, we can leave the meeting and can rejoin after 20 minutes. Madam, you are mute.
Sir, sir, we will take a 5 minutes break or
Give me 20 minutes.
20 minutes, sir. Okay. Now, how
15
much is the
minutes.
time, sir?
15 minutes. 15
15
minutes.
minutes, sir.
Yeah.
Okay, sir. Okay, sir. 10, 15 minutes. Please, all the participants, be stay here. Sir will be joining us another 10 minutes, 10 to 15 minutes.
3:40. Okay, we will join 3:40. Okay.
Okay, sir. Okay, sir.
Thank
Sir,
you.
please, all of you be here.
Thank you,
Thank
ma'am.
you. Thank
I
you.
can leave the
Thank you.
meeting.
हाँ सर,
Thank you.
आप फिर से ज्वाइन हो जाइए सर.
Yes, okay, ma'am. I will join.
हाँ हाँ, जल्दी ज्वाइन हो जाइए. Dear participants, so test will be conducted from 6:30 to 7:15 p.m. today. As already they have given the timings, time setting. 45 minutes will be provided to you for test, online test. and 30 questions will be asked. And last 15 minutes, you can use it for the feedback. After then, the 7:30 onwards, 7:30 to 8, you all will be, we will be welcoming you for the valedictory function. So, and during the test, the camera has to be turned on while giving the test. So, this is there. Okay, 10 minutes you can take the break and please rejoin. Don't leave it, please be here.
Madam, we have to log
Yes.
in the ATAL,
Yes, sir. Yes, sir.
for
In
the
your
test.
dashboard, in your dashboard itself, sir.
Dashboard also available, madam.
ನಿಮ್ದು ಲಾಗಿನ್ ಕ್ರೆಡೆನ್ಷಿಯಲ್ ಇರುತ್ತಲ್ಲ ಸರ್, ಲಾಗಿನ್ ಕ್ರೆಡೆನ್ಷಿಯಲ್ ನಿಂದನೇ ಜಾಯ್ನ್ ಆಗಿ ಸರ್.
ಜಾಯಿನ್ ಆದ್ಮೇಲೆ ಅಲ್ಲಿ ಅಟಲ್
ಹಾ
ಇದರಲ್ಲಿ.
ಎಸ್ ಸರ್. ಅಟಲ್ ಸೈನ್ ಅಪ್ ಮಾಡ್ತಿರಲ್ಲ ಸರ್.
ಎಸ್ ಮೇಡಮ್.
ಸೊ ದೇರ್ ಇಟ್ ಸೆಲ್ಫ್ ಇಟ್ ವಿಲ್ ಬಿ ದೇರ್. ಅಂಡ್ ಫೀಡ್ಬ್ಯಾಕ್ ಆಲ್ಸೋ ಅಲ್ಲೇ ಕೊಡ್ಬೇಕು ಸರ್ ದಿಸ್ ಟೈಮ್. You have to give the feedback in the portal as well as ours.
Okay.
And that will be considered as an attendance link for feedback, whatever I am sharing now.
Okay.
And test will be, sir, cameras has to be enabled.
Okay.
And those all other things that is copy and paste, the things all will be disabled by them, sir.
Okay, madam.
Whatever the things are there, na, sir, that will be there.
Okay.
Okay, sir. Thank you, sir. Thank you, sir.
Thank you.
Be here, sir.
Hello.
Ah, sir. Hello, participants.
Yes, ma'am. Good afternoon, ma'am.
Good afternoon. Sir has joined. We will start the second session. Good afternoon, sir.
Good afternoon. May I start?
Yes, sir, we can start now. All the, I think, participants are there here itself, sir. So once again, I welcome you all for the second session of the last day, 6-day FDP program. Dr. Sanjay Singla, sir, again, sir will be delivering the topic on GAN, that is Generative Adversarial Networks. Sir is a distinguished academician, sir, professor and research coordinator in the Department of Computer Science and Engineering with 23 years of rich experience and with 180 more than 180 research publications with patents and even I know that sir is heading around under sir 25,000 of intake is there in such a big university, sir, working over there, Chandigar University. We welcome you, sir.
Thank you, ma'am. Thanks a lot. Thanks a lot.
Thank you, sir. Thank you so
Okay,
much.
I start. I am host. I can share my PPT.
Yes, sir.
Thanks again for providing me the opportunity and giving me the opportunity for my second talk. That is a generative adversarial network on 6th of September 2025 on occasion of the ATAL FDP, emerging trends in AI for smart innovation and sustainable technologies for Industry 4.0. Today we will discuss about the GAN, that is a generative adversarial networks. It is a neural network. It is a class of neural network. And means listen network. This is a neural network. Okay, that's why. So it is a powerful class of neural networks that are used for unsupervised learning. So means it is focusing on the unsupervised learning. So this GAN has a two neural networks. What is called discriminator, second is called generator. This is a discriminator and a generator. So before going to these, we first learn about the learning. What is the learning? What is the unsupervised learning? Unsupervised learning. When then about the neural networks, these topics we have to cover to understand this GAN, and then about this two parts of GAN, that is a discriminator and generator. Machine learning, we know a learning is any process by which a system improves its performance from experience. Means human beings, animals, whatever, they learn from their experience. So means learning always improve performance from the past experience. So this is a learning. This is why explained by the this statement is given by the Herbert Simon. Another this machine learning statement is given by Tom Mitchell in 1998. Machine learning is a study of algorithms that improve the performance P on some task at some task T with experience E. P is a performance, T is a task at E. Again, when we perform same and same task, so our learning, previous learning will helpful, and our performance will be improved with the time, with the experience. So this is a defined by a triplet that's called P for performance, T for task, E for experience. This is a definition given by the Tom Mitchell. Traditional programming and today machine learning, there are difference in the input. Earlier data is there as input, program is given as input, and output was through the computer processing. Now data is there, our output will be our input. This is a feedback. In college system, university system, there is a feedback mechanism. So as a teacher, we understand this feedback is not good. Okay, peer review is not good. Student feedback is not good, but our HOD feedback is not good. HOD comes and sitting up in the class, but that improve our performance because they give the output. You are lacking here, there, whatever. Okay, so you have to improve your skills. So this feedback as an input is a two-day time, that's a machine learning. Every time what the system performance is there, we will check out and give the output. Okay, this there's some error. Okay, root mean scale error. Error has to be minimized. The system has to improve more and more. This is a performance. This will improve the performance of the system. That is a machine learning. So in 1959, Arthur Samuel gave a statement. Machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. Means in a traditional way, you will not program the machine. It will be learn from experience. It will be learned from the experience. Like chess player. Chess player first he will lose the game. Next time he will again lose the game. From his past experience, he will learn more and more and more. And this 2 year, 3 years child, after 5 years, will be too much skill in the chess. He can win any condition and he can beat any player because of past experience. He learned. He not is explicitly programmed. He learned from the experience. So this is a same time. Machine is there. Machine has to be learned by the previous output. This is a machine learning. Machine learning applications. You understand first. We are not going in the deep. For GAN, we need this learning. This is the autonomous cars. Autonomous cars. This is a state in the USA that made it legal for autonomous car to drive on road in June 2011. In 2013, four states in US, Nevada, Florida, California, Michigan has legalized autonomous cars because they learn unsupervised learning. They learn from the previous examples. These are cameras. All our cameras are there for the autonomous cars. This is the input image is given, half face postures are given, and system learn to make a complete picture of the face using the deep learning models. So bottom up and top down inference is there to make this like a complete face from the half faces, half posture samples. So this is a machine learning applications. Now we come to the again machine learning because we have to focus on our topic that is a GAN is a unsupervised machine learning. One is a supervised learning, second is unsupervised, third is a reinforcement. So means we will train models on the label data to predict or classify new unseen data. We will train the model on the label data. We know the outcomes. We will train the model. So we'll check the example in the next class. Next slide. Unsupervised, we already discussed in the previous. We find patterns or symptoms or groups in a unlabeled data. This is called clustering, or we will dimensionally reduce the dimensions in the unsupervised. Reinforcement learning, we learn through trial and error, and we will try to maximize the rewards and help in the decision making task. This is a reinforcement learning. This is supervised. We have a label data is there. Label is this is elephant, this is cow, this is camel, all given to our algorithms. Algorithm process it. When the any input come, to it will classify. This is an elephant. This is a camel. This is an elephant. This is a cow. All because it is a label data is given to the system, to the model, and model process it. Model knows this shape belongs to elephant, this shape belongs to camel, this shape belongs to cow, and it will classify. This is a supervised. It will work on the label data. This is label data. This is label data. Output is a labeled. Unsupervised learning, unlabeled data is there. Data is unlabeled. No cow, no camel, nothing is given. Unknown output, no training data set is there. It will be interpret itself. Check the common symptoms and cluster them in a group. There will be processing. After processing, there is a group 1, group 2, and group 3. So this is a clustering example where data is unlabeled. So our GAN is a unsupervised learning. Example of unsupervised learning. Understand? Where data is unlabeled. No marking on data is given. So our GAN is unsupervised. Third one is a reinforcement. We will go for the trial and errors to maximize rewards. So this is a agent is there, action, and reward will be there. This reward can be punishment. This can be some tip, positive or it can be negative. This is a reward. So we learn from the punishment or awards or rewards. Okay, positive or negative is there. Like it, if we give a tip to the waiter understand he served well. We not give the waiter any tip, give a complaint to the manager, hotel manager. That means the input is given to the waiter that his behavior, his service is not good. That is called reward. Okay. When a driver or a new person come to your city, Kalaburgi, and at a time of official time in or time out, he drive a car from his college to his home. Then he check this road is a having traffic. It will take another time. He will take an alternate route or will avoid the traffic. So this means he understand the traffic pattern by reaching the home later earlier. So this is a way of the reinforcement learning. We understand one part is a unsupervised learning. We understand this part. This is unsupervised. Now we have to cover this second one, neural network. First is complete. Unsupervised learning means data is not labeled. We have to give a clustering. Okay. The second is a neural networks. Then third is a generator and discriminator. So we have to cover this. I am audible? I am audible?
Yes, sir. Audible. Audible.
Okay.
Yes, sir. Yes, sir.
So we understand the unsupervised learning. It means unlabeled. We go for the neural network. NN. It is also called NN, neural networks. So this NN this neural network, they are the machine learning models that mimic complex function of human brain. In our brain, we also have neurons, neuro. Our mind has a million or billion trillions of neurons that together make a networks that are called neural networks. Okay. That has a memory, that have function, that can feel experience, that can perform well. So this is a neural networks in the machine learning models. They also resemble with the human brain neurons. This neural network model consists of interconnected nodes or neurons. The neurons are interconnected like a human brain that can process the data, that can learn patterns, and enable tasks such as a pattern recognition or decision making. That's why human beings can take a decision. Human being on previous on his previous experience. Okay, this is our activation function. This is the inputs to the neuron. Okay, and this all output of this neuron will be activation function G. Weights, every input has some weight, W1, W2, W3. Input X1 has a weight W1, X2 has a weight W2, Xn has a weight Wn. So all will be W into X. Plus this bias input will be there. On this we can use different activation function, sigmoid, whatever, Gaussian, whatever. And depending on our application, we can use different activation function, and it will be our whole output. So this is a neuron function. We understand this neural networks, we understand this unsupervised learning. Now this GAN we have discussed, this is a has neural networks. We understand neural networks. Now this is also NN neural network. This generator is also neural networks. In GAN, these two perform the all functionalities. This is a bit of, again, that is called generative adversarial network. It is made up of two neurons networks that is called discriminator and generator. GAN helps machine to create new realistic data by learning from existing example. It means from existing examples, it will create new or realistic data. This is a property of GAN. This term was introduced by Len Goodfellow and his team in 2014. They have transformed how computers generate images, videos, music, and more. All new images, videos, musics because of this GAN. Okay. Unlike traditional models that only recognize or classify data, earlier machine learning models classify data. They take a creative way by generating entirely new. This create entirely new content that closely resembles with the real world data. That resemble with the real world data. They means this create new realistic data. They create realistic data. This ability helps various fields such as art, gaming, healthcare, data science. So we will understand GAN and its scope further. The two parts generator. It will generate. It will learn to generate plausible, believable data. It will generate the data. It will generate the believable data. Create realistic looking data. Not real, but it will try to make realistic data. It will try to generate that is a actual realistic data. Images, videos. The generative instance become an active training example for the discriminator. Its input goes as a its outputs goes as an input to the discriminator. It will become an active training example to the discriminator. Its output goes to as an input to the discriminator. The discriminator's task, the task of generator is to generate realistic data and give the input to the discriminator. The discriminator task is to distinguish, to compare between real data and the fake data. Fake data will be generated by the generator. There is a real data and fake data. It will be compared. This is a fake data. The generator has generated the fake data. That penalty, the discriminator penalize the generator. It will penalize the generator for producing implausible results. It will penalize. If there is difference in the actual data and real and fake data, generator will be penalized. So this is a two-way. That is called adversarial. Both are giving input and giving input, their output, their output as input to the both are working in the adversarial way. He tried to make generator tried to make discriminator full, or discriminator want to differentiate between the actual data and the fake data. Yes, generator, you have generated the fake information. This is not a real one. This is the first picture, generated data by the generator. This is real data. Discriminator will check. This is the fake or real. This will check the fake and real. Yes, it is a fake. Some difference. Again, it will try to make this one. This is again fake. Discriminator will be able to differentiate between the fake and real one. Fake and real. This again, then this output, this is a fake, this is a fake. Generator will go for the more and more iteration, more and more loop, more and more generation, and finally it will produce the output. It will produce the output. This one and this one. This is a real, and this was a fake generated by the generator. And this is a real. It will be not able to differentiate. These are the which one is a real. So now the main task of this generator is to make this discriminator full. FWL full. Okay. So that discriminator not able to identify the difference between the real and fake one. This is the main outcome of the GAN. This is the main outcome of the GAN. Okay, two should be not comparable. Both should be same. This is it. This is the main output. Okay, means both are working in an adversarial way. Both are working, try to prove fool to each other. That is called adversarial. You understand network? This is neural network. We understand adversarial because they work in a not in a friendly way. They will work in an adversarial way. Generative means it will create, it will create. It is a generate new images, new images, new images, new videos. So that is what called generative. That's why the name is a generative adversarial network here. Ground truth, adversarial truth. This is again, this is the magic of GAN. It make the same picture, magic of GAN. Which one of computer generated? Actual picture and this is computer generated. The system is not able to differentiate between actual and the computed generated image. That is the power of the GAN. That is the power of the GAN. This is a some image, some input is given, and system is able to generate the realistic images. This is the magic of GAN. So in this way, GAN is able to generate realistic images there. So this is a discriminator. This is a generator. This is a discriminator. This is a generator. The real images, one input is real images, and generator random input is given starting whatever. Generator will be generate the fake image. This will go as a input to the discriminator. Discriminator check it is a real or fake. Yes, it able to. This is real. This is fake. A fake input goes to the generator. It will give to the generator. It will again produce the image till both become real. Both become real. This is working. So they are working against each other. That's why it is called adversarial. Again, use adversarial training. It use adversarial training to produce artificial data that is identical to the actual data. So that's why it is called adversarial. Which drive both network towards advancement. So both the generator will be tried to make more realistic images. The GAN are providing to be highly versatile artificial intelligence tools, as evidenced by their extensive use in image synthesis, style transfer, text to image synthesis, image to text. So these are the used GAN. GAN is used image generation, video generation, whatever. So they have also revolutionized this generative modeling. They have revolutionized. So discriminators, this is generator, real image, sample discriminator, random input to the generator. So this is a there are two penalty, loss for the discriminator loss, generator loss. Both the generator and discriminator are neural networks. We have discussed. The generator output is connected directly to the discriminator input through back propagation. Means loss will be there, this loss will be there. The discriminator classifier provides a signal that generator use to update its weights. So this loss will be held by the generator to update its weights. So that because there is input is already given, weights will be updated in the neural networks. Weights will be inputted in the neural networks. 1 second, I have a call. I can take the call. Sorry, there is a urgent call. Okay, thank you. So we will start continue our. PPT is visible.
Yes, sir. Yes, sir.
Yes.
Yes. So this is a now how this generative adversarial network works. The generator starts generating random data, such as an image, your face, or handwritten digits. The discriminator then check or evaluate these generated images, try to differentiate between the real image and the fake one. It will try to. As the discriminator gets better, the distinguish between the real and fake images, the generator adjusts its parameter or weight to produce more realistic looking images. Means if a generator is able to find the difference between the real and fake, so the generator it is a penalty for the generator. Generator has to adjust its weights. This back and forth process continue till generator is able to create images that are indistinguishable from the real one. Means till discriminator becomes a full. So this is a main target for generator. That I have to make the discriminator full so that the discriminator not able to differentiate between the real and fake images. And discriminator try to make I have to give a penalty to the generator. The image generated by the generator is not equivalent to the real one. They both are working towards the making imposed penalty to each other. The genius of GAN is lie in their ability to learn from each other through their reversal process. So both are working in the opposite direction. So both are learned from this one. If the penalty for the generator is will updated weight. If the weight loss is penalty for the discriminator, the means generator win and image is a real. So this is a diagram. Real data means discriminator. It is a correct node. It will go to the generator. Again, this generator input output will be input to the discriminator. Discriminator penalty will be for the generator. So this is a fine tuning till this process going on till this is a discriminators not able to differentiate between the real and fake image. So discriminator is simply a classifier. We try to distinguish between the image created by the generator and the real image. It could use any native architecture that is able to classify. It is a classifier sample. It is a classifier. Okay. So under the classification discriminator, it will classify. It will be make a loss. It give this is back propagation. If the loss is for the discriminator, it will be update its weights. Discriminator training data comes from two sources: real data, this is real images or real data, a fake data that is data generated by the generator. So during discriminator training, the generator does not train. When discriminator become full or till it become full, it will not update the weight. It will update the weight, then become a full after that. So that will be another time. It will come up with a strong discriminator, as a strong discriminator. So there are two losses are there: generator loss and discriminator loss. During training, discriminator ignore the generator loss. During discriminator training, it will use the only discriminator loss. It will ignore the generator loss. During discriminator training, discriminator classify the real data and fake data. Discriminator loss penalize the discriminator for misclassifying the fake and real one. This updation in the discriminator through the back propagation. The generator part of GAN learn to create a fake data by incorporating feedback from the discriminator. It learns to make discriminator classify as a output as a real. It will be meant is main aim of this generator is that discriminator should classify its output as a real. Generator training required tight integration between the generator and the discriminator because it depends upon its winning score depend upon the discriminator output. So the portion of GAN is a random input. There is random input, generator network, discriminator network, discriminator output, generator loss. There are some information for the part of the generator. Convergence. As the generator improves with the training, discriminator performs get worse because discriminator convergence when discriminator is not able to differentiate between the real and the fake. That is a convergence. Loss function means that reflect the distance between the real and the fake. Loss function. So there are two type of loss calculation: minimax loss and Westerian loss. There are two type of loss function in India. So minimize. This is the minimax loss. So this is DX, discriminator estimate. Discriminator is a data instance is real, and this is a overall evolution or real overall evolution EX of the real data. This is real. DX is a real. This is GZ is a generated outputs, and discriminator estimate. This one is a discriminator estimate. The fake instance is a real. Fake instance is a real. EZ is a expected value of all random input to the generator. All random input to the generator. Random inputs के base पर, this is on the random input base. What is the expected value of the random input? What is the real input? This is. So it should be maximized. It should be maximized. It will try to discriminate, try to maximize. Maximize means there will be difference between the real and the fake. So this is a generative will try to minimize. This is a both will be reversible to each other. And second is loss is a we can take in our implementation minimax loss or Westerian loss. Why it is called minimax? Because discriminator try to make it maximum. A generator try to make it the mini. So that's why it is called minimax loss. And second is a Westerian loss. There is a DX is a discriminator generated output. This is a generated output evolution. This is a generator loss. This is a discriminator loss. So it should be loss will be there. The discriminator try to maximize this function. So it will try to maximize the difference between the output on the real and output on the fake. When this will be large, generator loss, this will be large. So value will be near to 0. 0 means now this will go for the convergence. So for imaginations, data augmentation, anomaly detections, image to image translations, drug discovery, so all these applications, the GANs are very useful for all these type of applications. So, sorry. This is about the GAN. So, this is about all about the GAN. So we will go for the some type of implementation for the GAN. So we have import torch neural networks, matplotlibs and numpys. We have a transformer. We have create new tensors. Basic transform we have made it, and we have a data sets. We have loaded on our data set, training data sets for transformer. There are some parameters are there, number of iteration is there, latent dimension will be there. These are some parameters. We have hyperparameter set. Generator, yes, we have generator we have studied the generator as a neural networks. Okay, so we have taken ReLU function for the generator activation functions. So, and we have used convolution networks there. This is about, and we have set up the convolution network for our neural networks, and ReLU function is somewhere in the activation function is there. Then same for the discriminator, we have set up ReLU functions and convolutions. We have make it, and we will define the generator and the discriminator. Then will be optimize the results through the optimizer and training loops, because loops will be according to the epochs, number of time epochs. So it will be try to generate the images. This is the epochs. I will try to run it, but time taken was enough number of hours. You understand? Take a lot of time. I think there is some issues coming. Yes, we have towards this all are important. Basic transformer is given, training sets, data sets imported. Parameter set, generator is done, neural network is done, discriminator done. We have initialized the generators and discriminator, all are set. Now training. Because this training takes a lot of time to generate images, fake and real one. This is a time given, 21 seconds. Approximate, it take 30 minutes to run. Because RAM is so this will take a lot of time. If you require, I will share the code also. No issue. So I will share the output also after some time because it's running. So it will generate the images, real image and fake image. This one. This is real loss and fake loss. This is a discriminator loss and generator loss. So this will be generate the loss. So this will go as a penalty, and this will work as a feedback to the system for the generator. Again, mainly is used for the generate the images. Okay, and that is a realistic images. So this one, starting. This is a loss, discriminator loss. 1 second. This is generator loss 1.55. Too large. Next epoch we will check it. I have a connection 5G. Still there is some issues coming. We will check one output more. Then we'll try to finish it. Okay. One output take I think 2 minutes. So this will be tried generator loss will be try to minimize after each and every epoch, and discriminant loss will be high, and this will be adversely affect, and this one loss will be going down. Understand? This is a again. This will be going for the realistic images are generated according to the realistic. So this is a way. This is a beauty of the GAN. Okay. So I think I should be stop here. If you need any help, any question, any queries, you can send me the email also, or you can call on my number. Yashri ma'am. Hello.
Hello?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
from
sir.
my side.
Any questions, participants?
Yes, good evening, madam. Good evening,
Good
sir.
evening, sir.
Sir, how does GAN handle generation of new unseen data?
Hello. Yes, sir. Yes, sir. Please.
How does GAN handle generation of new and unseen data, sir?
Sir, actually, you have to give some random inputs. Okay.
Okay.
You have to give random inputs, and you have to put some images that is a realistic as a input to the discriminator.
Okay, sir.
Understand? No?
Yeah, yeah.
Then it discriminator will be match them. Give a feedback to the generator. To
Okay.
depend upon it, I'll give an example. Okay, I'm giving an example.
Yeah.
Suppose we have a database of 1,000 criminals.
Okay.
Hello,
Yeah, yeah, sir.
Shanta Kumar sir.
Yes, sir.
We have a database of 10,000 criminals. Okay,
Yes, sir.
so you know about the term latent fingerprints.
Yes, sir.
Latent fingerprints is the fingerprints of the criminals at the
Yeah.
site which are not visible.
Correct, sir.
Okay, means they are not because criminals are very intelligent. They not give their fingerprints
Yes,
or
sir.
any knife or any tables or any surface.
Yes, sir.
These fingerprints are either incomplete or not fully visible. Okay,
Yes, sir.
so that will be work as an input to the generator.
Mm-hmm.
That fingerprints
Yes, sir.
or the generator we will give the actual database to the discriminator.
Okay, sir.
So system will be generate
Mm-hmm.
automatically the fingerprint that matching with the actual criminals.
Okay, sir.
This is a very good application of this GAN.
Yeah, yeah. Yes, sir. Understand, sir. Sir, how can we evaluate the performance of the GAN?
I have shown the slide now when the loss of the generator loss will be near to the zero, sir.
Near to the zero, sir.
Yeah, approximately zero. When epochs will be never in epochs, generator losses are nearby zero or no change in the 10 or 20 epochs.
Yes, sir. Yes. Okay, sir. Thank you, sir.
Thank you, sir. Thank you. Thank you, Jai ma'am, to giving me
Sir,
opportunities.
one more, I think question is there in the chat box, sir.
Yes. Anyone is there? Want to ask question?
Yes, sir. Question is there in the chat box, sir.
Chat box. Okay.
Chat box. Two questions are there.
I am not able to find madam question.
Sir,
Anyone?
it is from Aniket, sir.
So
How
chat.
does how does a generator works? What kind of data sets are used by a generator to generate synthetic images? Are the data sets made up of images or textual images? Textual data. It's in the chat box, sir. You go to chat box.
I'm clicking on the chat box, but there is a name of participants is coming.
Sir.
But
No, the
okay,
participant.
okay.
One more
Yes. I've seen. Okay.
chat box, sir.
Yeah.
Meeting
So
chat.
how does the generator works? Okay.
Huh,
What
huh.
kind of data sets used by generator to generate synthesis image? So actually, for images, Aniket, we are using the images, or for generating the real images, we can give the videos. It can be generate video. It can generate digital digits, or it can generate very well. Mainly used for the images. Okay, image and videos. When you go for the chat GPT and give a generate an uh, tree, or make a tree, make a scene like this. So this is actually given by the GAN. Okay, this is Ankit. Okay. Second question, sir, how does the generator works? What kind of data sets? Same question is there. The images only.
Above
Will
that,
you?
one more is there.
Okay, sir. Thank you for the response. Really appreciate. Thank you.
Sir, above that, one more question was there earlier. Um,
Feedback on attendance.
you know,
Okay, I check it.
sir, what type of data we need to give as input, and like angles, faces,
Already,
ID, how to give? It's over, sir.
ma'am, you can take any raw images
Okay, okay, okay,
and it
okay,
will be
sir.
matched with the real images. No?
Okay, okay.
When the raw image is not given properly, the generator loss will be too high. Okay. When the resemble image, fake image is a resembling, little bit resembling, generator loss will be low. Automatically, it will take more epochs if the generate input, raw input is images are not correct. It will take a more epochs to give a realistic, but it will reach or try to reach the realistic image. No issue. Okay. Suppose you have given a face, half face, and realistic image is a full face. It will generate the half face into a full face with some epochs. JMM,
Sir, yes,
well,
sir.
yes.
Is there any questions? Is there any question? Sir, I think no
No.
question, sir.
No, madam.
No, thank you, sir.
Thank
Thank
you
you so
everyone
much.
for joining me and giving you time. I'll listen me patient. Thanks a lot. Thank you, JMM. Thanks a lot.
Thank you, sir. Thank you so much for accepting our last minute changes. Also, you agreed, sir. And I got relief, a big relief by getting your support, sir, that day. Thank you so much, sir. Thank you so much. Thank you all the participants. Please stay here another 5 minutes. The